Welcome to Lesson 10. We are continuing with our study of line plots. Some more practice with our line plots. I put a nice picture here of all of us when we were together when we went on our fun field trip to the library. Take a look at that picture. I know you miss your friends. This is when we were all in our group together. All right, let's get started. Okay, so we're going to look at lengths of butterfly wingspans. Okay, we're going to look at the mixed numbers at the bottom. Those mixed numbers are inches. So it's how long the butterfly's wingspans are in inches. 1x is what? One butterfly. So how many butterflies had a wingspan of 3 7/8? 1. Because there's 1x up there. Okay, how many butterflies had a wingspan of 3 3/4? 3, because there's 3 x's. By the way, our expectation is that you have pencil and paper. You have pencil and paper with you. You are working out the problems. You do not need to draw the line plot, but you need to write equations. You need to solve. When I solve, you are solving. When I ask a question, you're answering. There may not be anyone that can hear you there, but if you answer, it goes into your brain better and you are actively engaged. So when I ask a question, you are actively answering. All right. I want you to bring your attention to the fact that there's different denominators on this line plot. So for example, we have 3 1/2 on our line plot, but we also have 4ths and 8ths. Okay, so why are we allowed to have halves, 4ths, and 8ths? Because halves can be equivalent to 4ths and 8ths. So for example, they wrote 3 1/2, but they could have also have written 3 2/4. If they wanted to use 8ths, what fraction or what mixed number would be equivalent using 8ths? 3 4/8 would be equivalent. So you could have written 3 2/4, you could have written 3 4/8, you could have written 3 1/2. And why are they doing this? Just to make it a little bit more complicated. Make you have to really understand what you're looking at. Okay? Let's take I want you to look over I'm erasing, bear with me. All right, I want you to look at these 3 fractions right here. Okay, so we've got 3 5/8, 3 3/4, and 3 7/8. Why? How do they go from 8ths to 4ths back to 8ths again? How does that make any sense? There should be 8ths right there, right? Like if this is 3 5/8, this should be 3 6/8, and this one is 3 7/8. Then you would be counting correctly. And then what would this one be? This one would be 3 4/8. So then you'd have 3 4/8, 3 5/8, 3 6/8, 3 7/8. So 3/4 and 6/8, they must be what? 3/4 and 6/8 must be, that's right, they must be equal. In order for that to work, those fractions must be equivalent, 3/4 and 6/8, or else you would not be allowed to put that there. Okay? Again, why don't they just put 6/8? They just want to make it more difficult for you. So we can prove that they're equivalent by cross multiplying. And they are. Okay? All right, so these little things make your line plots a little bit more difficult than your normal straightforward line plot. All right, so let's get into our questions here. How many butterflies had a wingspan of greater than 3.5 inches, but less than 4 inches? Greater than 3.5 inches, but less than 4 inches. I'm letting you look at the line plot before I just give you the answer. Greater than 3.5, less than 4. So we need numbers that are to the right of the 3.5 and left of the 4. That would be these. Greater than 3.5, less than 4. How many butterflies? Count them. One, 2, 3, 4, 5, 6, 7, 8, 9. 9. One butterfly is 1x. All right, what is the difference, keyword, between the greatest wingspan and the smallest wingspan? We need to write what kind of an equation? We need to write a subtraction equation. We need to find the difference between the greatest wingspan. Oh, wait a minute. Why am I writing 4? I'm writing 4. Well, why should I not be writing that? That's right, because there's no X's up there. There were no butterflies with a wingspan of 4. All right, so not 4. That's not the greatest wingspan because it never occurred. No butterflies had that. The greatest wingspan that occurred was 3 7/8. What's the difference between the greatest and the smallest? The smallest wingspan is down here. Not 3. There's no X's up there. So 3 1/8. 3 7/8 minus 3 1/8. 3 minus 3 is 0. 7/8 minus 1/8 gives us 6/8. That's your final answer, 6/8. All right, number 3. Oh, sorry. Number 3, how many butterflies had a wingspan greater than 3 4/8? Ooh, wait a minute, I don't see 3 4/8 on there. Why don't I see 3 4/8? Why don't I see it? This is when you should be answering a question out loud, talking to your stuffed animal, talk to your dog, your cat, your gerbil, your hamster, your brother, your sister, talk to yourself. That's because 3 4/8 is equivalent to 3 1/2. We're looking at, it's really saying how many butterflies had a wingspan greater than 3 1/2. Here's your 3 1/2. 0 butterflies. Didn't happen. There's no X's. What is the total wingspan of the butterflies that measured 3 1/4? So you've got 3 1/4 4 times. 3 1/4 4 times. Now, you do not know how to multiply mixed numbers, so we're writing it as repeated addition. Let's add the fractions. 1/4, 1/4, 1/4, 1/4, 1/4, 2/4, 3/4, 4/4. Add the whole numbers. 3, 6, 9, 12. All right, 12 4/4. That 4/4 is really a whole. 12 1 gives you 13. 13 inches. 13 inches was the total wingspan of the butterflies that measured 3 1/4 inches. All right, last question, and then you've got a different line plot to work on your own. One butterfly has a wingspan of 3 7/8 inches long. That's this butterfly right here. How much longer would his wings need to grow to reach 4 inches? So you have 3 7/8. How much would it need to grow so he could have a wingspan of 4 inches? What would you add to 3 7/8 to get to 4/8? How many eighths does it take to get, we want this whole to become a 4. 7/8. 1 more eighth will give you 8/8. And if you have 8/8, that would be equivalent to a whole. So it would be 3 and 1 whole, and that would give you your 4. 7/8 and 1/8 give you 8/8 plus that 3. Okay, so he needs to grow 1/8 inches longer. All right, okay, so you're going to practice now. This is your line plot, and you have 5 questions, and you will need to be ready to go over those 5 questions when we meet today. I suggest you number your paper 1 to 5, and you write the answers so that you're prepared to share them. All right, see you when we meet.